We're really just going to do some examples from 4.4 so you can see that they're actually the same problems. So to start out, the first problems in the sections are very literal. They're, the sum of two numbers, a number plus 3 minus 2 times the number. Things that you can translate literally into math. So here's 4.4. Again, the exact same types of problems. The only difference is word problems. Okay, I'll highlight a couple specific ones. So number 2 is the sum of two numbers is 5. When you subtract them, the difference of the two numbers is -3. Wait, is 13. Okay? So that's the question, and it says, find the two numbers. Okay, so our goal for this whole section is to turn this word problem into 2 equations with 2 variables. Okay, so let's get the first equation here.
X plus y equals 5.
Exactly. Any two numbers, in general, if there's a story, we want to choose a letter that goes with something, like adult, we would choose A, or kid, we would choose K. But then there's just any two numbers. X plus y equals 5. And the second one, the difference of two numbers is 13. Yeah, exactly. X minus y equals 13. And then now it's just like section 4.1, 4.2, 4.3. You can choose whatever method you like. In general, most people choose 4.3. So what could we do? Yeah.
Cancel out the y.
Exactly. Let's just add them together and cancel out the y. So x plus x is 2x. Y plus negative y cancels. 5 plus 13 is 18. Divide by 2, divide by 2, x equals 9. Okay, just like all of chapter 4, we plug that back in anywhere. I'm going to plug that into x plus y equals 5 and get 9 plus y equals 5. So minus 9, y equals -4. And again, I'm going to write my answer as, 9, not 5. As a point, you could absolutely write it as x equals and y equals. Now you may have gotten the reverse of this because it just said any two numbers. So the order didn't matter. So 9 and -4 are the answers regardless of the order. -4 and 9, 4 are 9 and -4. Okay, we can plug it back in and check. Add those together, we do get 5. And take 9 minus -4, we do get 9 plus 4 is 13. Perfect. Okay. Choosing a problem a little harder. Let's look at 14. Okay, so 14 is talking about you have the perimeter of a tennis court is 228 feet. A player runs around a total of is 690 feet, which is equal to 7 times the length plus 4 times the width of the court. What are the dimensions? So find L and find W. Okay, so I shortened the paragraph a tiny bit, but really that's how it reads. Okay, so very literal. Alright, so what would one equation be? Again, we're talking about, I always draw my picture when I have a a shape, so whether it's a triangle, circle, or rectangle. So this is a rectangular tennis court. Okay, so what's one equation we could write for this? Yeah, Nick?
7 times L plus 4 times W
Yeah,
equals 690.
yeah, exactly. So that second one says, the player ran 690 feet, which was equal to 7 times length plus 4 times W. So that's one equation. Now we need another equation. What's the other one?
2L plus 4W equals 228.
Really close. Say it one more time, I think you just misspoke when you said it.
L plus W plus L plus W
Yeah.
equals 228.
So in other words, 2L plus 2W. You accidentally said 4W, but yeah, 2L plus 2W, yeah, equals 228. Or adding it up, yeah, L plus W plus L plus W is 228. Okay, so those are our two equations. Once you've set that up, it's just like every other problem in chapter 4. Okay, there's no differences. You choose your method, whether you want to graph, whether you want to use substitution or elimination. Yeah, Nick?
Multiply the top by -2.
Exactly. This one is harder. You have to multiply 1 by 7, 1 by 2. But if we just multiply the top times -2, we get -4 and 4. So this becomes,
-4L
yeah,
minus 4W
yeah,
equals some large number.
yeah, some large number. It's -456. And then this is 7L plus 4W equals 690. So, adding these together, we get,
3L.
yeah, cancel. And then some big numbers, that'd be 234. Which, just divide by 3, divide by 3. In general, in this section, you're gonna be dealing with numbers in the hundreds, maybe even the thousands. So just use a calculator if the numbers are difficult. It's the same strategy though. So dividing by 3, we get L equals 78. And then, we plug it into,
The top first equation.
yeah, either equation. The top one looks easier, so this would be below. I don't have space below, so I'll go over here. So this is 2 times 78 plus 2W equals 228. So 156, yeah, plus 2W equals 228. Subtracting 156, I get 2W equals 72.
Yeah.
Divide by 2, divide by 2, W is 36. Okay, so there's a two-part answer. You have L equals 78 and W equals 36. Or you could write it as, this is 78 feet by 36 feet. And again, the order doesn't matter for dimensions, but it asks for the dimensions of the report. Yeah, so either way you wanted to write it, either like this or like that, same thing. Okay, but the key being you need two answers because it's two variables. Alright. So another really, really common type of problem that you might see on, say, a test is that classic problem that you might remember from like grade school of, total I have 26 coins. I have twice as many nickels as dimes. How many nickels and dimes do I have? Or say, another problem might be like this. Say, there was a show and kids paid $3, adults paid $10 to get in. Total, there were 100 people that paid $300. How many kids and how many adults were there? That's a really common situation where you have a total number and a total dollar amount, and then you're going to use those two equations with two variables to figure out what you've got. So 22 is that type of problem. Okay, it's some special event for a minor league baseball game. It cost $5 for adults. It cost $1 for students. Okay, total attendance was $12.81, and total dollar amount was $3,425. Okay, really common type of problem. Let's turn this into a system of equations. Okay, what's one of the equations going to be? Or even before we do that, what would the letters be that we would choose here? Last time, length and width, we chose L and W. Here, what would we choose?
Negatives.
Yeah. For for adults, I would use A, and for students, I would choose S. And that's what the question here is find number of adults and number of students. Okay, so what would my first equation be?
A plus S equals 1281.
Exactly, so first is my total. Okay, so total I have 1281 adults and students. The second one's a little harder. Okay, so we've used this total attendance now. So now we need to use these prices and this total. An easy way to think about it is total, how much did all the adults pay?
A times 5.
Exactly, so that would be how much the adults paid, and then the students paid?
S times 1.
Yeah.
Equals 3,425.
Exactly. Each adult paid $5, so the number of adults times 5 is how much the adults paid. Plus, $1 each times S is how much total the students paid. And if you add that all together, you get that they paid $325. So this is total number of things, this is total dollar value. Really common type of problem. Okay, this one would just be X plus Y equals the total, and this one is dollar amount times adults plus dollar amount times students equals total dollar amount. And then you solve it like any other problem, right? What would be the easiest way to go about this probably?
Multiply the top by a -1.
Yeah, exactly. The numbers are already equal. We just need a negative sign here, so multiply by -1. So this would become, negative A plus negative S equals negative 1281. And then it would be 5A plus S equals 3,425. And again, you have a calculator for the difficult numbers. So adding these together, we would get 4A cancel equals 2,144. And then we would just divide everything by 4. We get 500, right? I did that right, I think. Yeah, so we get 525 plus 11, so 536, I think. Okay, and again, you have a calculator to do all that. Right? The arithmetic isn't what I'm testing here. Okay, you'll always be carrying a smartphone in your pocket. So plug that back in to either equation. Obviously, it looks easier to plug it into the first one. So let me just erase the work from this other problem. So now plugging this into A plus S equals 1281, we get 536 plus S equals 1281. So we subtract the 536, subtract the 536, and we get S equals 745, probably. I did not sleep much last night, so I might be doing this arithmetic wrong. Alright. But that's it. So the big scenario, and really common, I'm telling you, is total number of people and then total price. It's a really common type of problem. Pencils and erasers, dimes and nickels. I mean, they're the common problems you see on like, SATs, GREs, all these questions, okay? So that's where I'll stop. Just those are 3 examples of common problems you might see on a test or that you for sure will see on your homework. The rest of the problems are basically read the chart and use the chart and the paragraph to do problems. I would say that is less likely to show up on a test, but it is good practice. Oh, I thought that was an actual like eagle.
Sorry, my bad.
Okay. So yeah, so that's where we'll leave off. So you got 12 minutes to try a couple of those problems, but again, there's no new math here. All that we're working on is turning a word problem into a system of equations. That's it. And you'll see one of these on the test, okay?